This video is going to describe the work that we're doing at the USC Institute for Creative Technologies with the Primesense camera, which is actually the camera that's used in the Microsoft Kinect application for the Xbox, and our use of this camera to develop physical therapy, motor rehabilitation applications, essentially using virtual reality to motivate people to do physical therapy. Now you notice our user here is moving around on the screen. She's going to strike a calibration pose. And you notice a stick figure emerges from this. We can use this stick figure to actuate movement within a digital environment for the purpose of rehabilitation. So we're going to show a couple of ways that we've done this for specific motor rehabilitation applications.
We can track and integrate within the game any of these types of movements, whether they're gestures or if we're tracking certain points on the body, so the head, the chest, the shoulder, the elbow, the wrist or hand, and then the hips, the knees and the feet.
So the articulated stick figure here actually renders the movement of the user. And you'll note that we can put that on a little digital puppet here so that the character can move around, and it's a natural movement in 3D space as the user interacts. This provides us with great opportunities for designing rehabilitation apps. We can take that articulated skeleton and actually track that movement without any wires again with the camera, and the user can now drive this little penguin from the Tux Racer game down a ski slope and try to collect little prizes as she goes down. In this way, we can foster balance training. You notice as the user moves from side to side, the penguin moves from side to side. If she leans forward, it goes faster. If she leans back, it slows down. In this application, we actually take the input from the Primesense camera of the user's movement and use it to actuate a very basic game of Space Invaders. As the user moves from right to left, they can control the missile launcher down at the bottom, and when they want to fire, they move their hands out forward and it fires. So now we can take basic computer games that rely on a mouse and a keyboard and emulate the movements of the mouse and the keyboard, the activities on the mouse and the keyboard with actual body movement. This will open up a range of activities for actual physical therapy with games that people are already well familiar with. And it really is the future of virtual rehabilitation.
Having the ability to assign specific gestures or body movements to the game-based tasks allows us to tailor the game to specific therapeutic goals. This enables us to use the same game for a wider range of patients that have varying levels of ability and very different rehab goals.
Another example using the Primesense camera to track user movement is with this particular game called Jewel Thief. This is a game devised for helping people to interact with their upper extremities for reaching, range of motion, and so forth. But you see, as the user moves, they can interact with objects in a natural way. Again, not wearing any encumbering wires, markers, or LED lights. This is really the future of motor rehabilitation, and I think will significantly drive how users interact with digital content in a variety of ways.
The game encourages the player to reach for gems, and we can tailor the placement of these virtual stimuli within the game for people with different levels of balance ability. And we can assign the gems to light up in different patterns depending on the therapeutic goal.